Hi everyone, in this video I'm going to show you how to solve this exercise 4. So you have a plane wave travel in the positive y direction. So this refer to the k, unit vector k, in a lossy mediums. Okay, so these are the properties of these lossy mediums. And the plane wave has the electric field formulas which is equals to this at the positions y equals to 0. Okay, so now you have to find the electric field at the positions y equals to 1 meter. Okay, and the time is equals to 2 nanosecond. Okay, right. So let's look at the equations given. Okay, so the question gives us the equation of the electric field. However, this is not a complete one. Why? Because this is the formulas happen at the positions y equals to 0. Okay, so if you write down the general formulas for the electric field, okay, it will be amplitude, right? And because it is a lossy mediums, so usually you will have an exponent, okay, with the alpha. Okay, so since your plane wave is travel in the positive y direction, so here will be negative y, right? Okay, so I'm going to use the cos, okay, because the question say that it's a cos. So my angular frequency is this, right? And then usually we will have a minus beta y, right? Minus beta y, okay? But in this question, we have this pi over 4. So this shows that it has a pi over 4 over here. And the electric field is in the z directions. Okay, so when the y is equals to 0, what will happen here is this thing is going to be 1, right? And this thing is going to be 0. That's why you get a formula of this. Okay, formula of this. So this is not the complete one. So the complete one should be this one. Okay, so let me modify it, okay, by putting the value that I know into it. Okay, so I will replace the value of my amplitude, which is still 30. So I will put it here. Okay, so these will be the correct formulas. Okay, for my electric field. Alright, so now let's calculate. Okay, so the electric field, okay, at the positions 1 and 2 nanosecond. But before we do this, we have to solve for these alpha and also the beta. Then only we able to get the value. Okay, so for lossy mediums, remember what is the formulas for lossy mediums? Okay, the attenuation constants and also the phase constant. So it is a very, very long one for lossy mediums, right? Okay, so I will write down here for alpha is equals to omega, right? And then we have these properties, right? And then we have 1 plus, okay, over omega epsilon square. All right, so for alpha is going to be negative 1. Right, so now let's replace the value into it. Okay, so what is omega? 10 power 9 pi. Okay, so let's put the value 10 power 9 pi. Okay, and then what is the value of mu and epsilon? What is 4 and 1, right? So it's 4, okay, 1, okay, mu naught, epsilon naught, right? Okay, over here I have 1 plus, okay, conductivity, okay, is 10 power negative 2. Okay, 10 power negative 2 over, so 10 power 9 pi and 4 and epsilon naught. Okay, so I put in the value that I know and do it. Okay, right, so it's negative 1. It's negative 1. Okay, so I will calculate it one by one, part by part. Okay, so this is still 10 power 9 pi. And over here, I will have this 4 divided with 2. So over here, I have this 2.23 times 10 power negative 17. Right, negative 17. And over here, I have 10 power negative 2 times 10 power 9 pi plus multiply 4. Okay, so be careful of every single value that you key in. Okay, and then I square it. Okay, so it is 1 plus 8.078, okay, times 10 power -3. So I have to square root it, okay, and minus 1. Right. Okay, so I straight away use this and plus 1. And then I square root my answer. And then I minus 1. Okay, so here I get a very small values. Okay. Right, I get very small values. So here I have 2, 3. Power 9 pi. Okay, so I'm going to multiply with 2.23 minus 17, and I'm going to square root it. Okay, when I square root it, it becomes 2.99. It's almost 3, so I will write down as 3. Okay, 3 times 10 power -10. Okay, so when I multiply it, it becomes 0.94. Okay, so this is my alpha. So I will repeat the same thing for my beta. Right, the beta. What is the formula of beta? Okay, so the formula of beta is very similar, like you know. Okay, so it's 1 plus. Okay, then I have a square root, and for the beta is plus 1. Okay, so I will straight away replace the value that I used before when calculating my alpha. Okay, is 2.23 times 10. Okay, I will 2.23 times 10 power -17. Right, so basically this part is the same, so I will use this plus 1. So I will 1 plus 1 plus, then I have a square root, right? 1 plus 8.078 times 10 power -3, right? And then plus 1. Okay, so 1 plus 8.078 -3, and then square root answer, and then plus 1. Okay, so you get 2.004, right? 004, and 2.23 times 10 power -17, and then you have a square root. Okay, so times 2.23, then square root. So it's 21.02. Okay, so this is my beta. Okay, so I should replace my alpha and beta into my formulas. Okay, for me to calculate this electric field. Okay, So my electric field formula is the amplitude 30, yeah? 30 exponent negative 0.94. Okay, and the direction is y directions. So cos 10 power 9 pi t, right, and minus beta, okay, minus beta 21.02 y, right, and plus pi over 4, okay, plus pi over 4, and in the z directions. Okay, so when my y equals to 1 and my t equals to 2 nanosecond, 2 nano. Okay, so we have to replace the value. So 30 exponent negative 0.94, okay, and then cos 10 power 9 pi, and the t is 2 nano, okay, minus 21.02 plus pi over 4. All right, okay, so take notes here because you have to set your radians, your angle unit to be radian. Okay, radians. Okay, so let's calculate this. This is 30 so 10 power 9 pi times 2 nano is minus 9. Okay, and then minus 21.02 and plus pi over 4. Okay, so I get negative 13.95. So cos answer is equals to 0.185. Okay, so I multiply with 30 exponent negative 0.94. So the answer is 2.164 volt per meter, and it is in the z directions. Now we want to look for the question B. So the distance traveled by the wave to have a phase shift of 10 degree or 10 degree. Yeah? What does it mean? Okay, so it means that so this is your wave propagating, right? Okay, so they want you to find out how far your distance travel. Okay, distance travel, okay, for it to have a phase shift, okay, phase shift of 10 degrees. Okay, in general we can know the wavelength, okay, which is a distance here, okay, how much the wave travel, okay, by taking the 2 pi over beta. Okay, so this is the phase constant and this is the angle. Okay, the angle for a complete propagations in one cycle we have 2 pi. Now we are going to replace this with 10 degree. Okay, 10 degree. Okay, so for 10 degree, okay, we have to multiply with pi and divide it with 180 in order to get the radian unit of the angle. Okay, radian unit, so it is pi over 18. Okay, so now we want to know how much distance is traveled by the wave, okay, for it to have a phase shift of 10 degrees. So for the beta, okay, we will be using the beta 21.02. Okay, 21.02. Okay, and then divide with 21.02. Okay, so it's 8.303 millimeter. Okay, so when the wave travel 8.303 millimeter, it will have a phase shift or angle change of 10 degrees. Alright, next questions. We want to know the distance traveled by the wave. Okay, how long it traveled to have its amplitude reduced by 60%. Okay, it means that at the beginning of its traveling, okay, the amplitude is 100%. So travel for how far? Okay, it will reduce by 40%. It means that it still left 60%. Okay, so this is what we want to know. Okay, so let us write down the formulas. Okay, formulas of the electric field. Okay, so the electric field formulas, okay, is 20, right? 20, am I right? It's 30. Okay, so okay, the things that actually represent the amplitude of the electric field is these terms. Okay, so it's 30. Okay, exponent negative alpha is 0.94 y. Okay, 0.94 y. Okay, so when these electric field travel, okay, in the mediums, its amplitude will keep on dropping. Okay, so they want to know how far it travel for its amplitude to drop. Okay, for example, to drop by 40%. That means it's still left. Okay, it's still left. Okay, 60%. Okay, so first of all, we want to know how much is 60%. Right, if 100% is 30, okay, is 30, how much is 60%? Okay, if 30 is 100%, right? Okay, so what is the value when it is 60%? Right, so you will take 60 multiply with 30 and then divide with 100. Okay, so if you do like this, it means that, okay, this is the value that you want to get. So 100, okay, multiply with the question mark is equal to 1000, right? Is equals to okay, is equals to 18. So meaning that initially is 30. Okay, so when it reduced by 40%, it still left 18. Okay, so what value of y, okay, will make the amplitude to become 13? Okay, so you put out this together. Okay, you want to find out what is the y, so that you can get your amplitude to be 18. Okay, you need to solve for this y. Okay, so exponent negative 0.94 y is equals to 18 divided with 30. Okay, divide with 30. So you have 18 divided 30 is 0.6. Okay, to solve for this exponent, we use the ln. Okay, we use the ln at both sides. Okay, ln 0.6. Okay, so this one will become negative 0.94y, and you press calculator ln 0.6, you get negative 0.51. Okay, so your y will be equals to divide with negative 0.56, so is 454. Okay, so when you travel for 0.54 meter, okay, the amplitude will drop to be 18. Okay, so this is the answer. Alright, last one we will look at finding the h at the position y equals to 2 meter and t equals to 2 nanosecond. But before we calculate this value, we must know what is the equations for the magnetic field. Okay, we only know the equation of electric field from the questions, right? So we need to find out what is the magnetic field equation. So for magnetic field, okay, the general formula or equation is amplitude. Okay, this is the alpha, right? So we have cos 10 9 pi t, right? And then we have minus what is the beta? I forget. The beta is 21.02, 21.02 plus pi over 4. Alright, and then the H directions. Okay, we need to figure out the amplitude and also the directions. Okay, so for the directions, we can use this method. Okay, so for the electric field is in the Z directions. Z directions. Okay, magnetic field is this, and this is, oh, I have Y here, okay, and over here is positive Y directions. So over here is equal to X, right? ZX equals to Y. Okay, right. And now for the amplitude. Okay, for the amplitude, we have to use this relationship. Okay, we have to use this relationship, but we don't know what is the intrinsic impedance. So we have to calculate it, the intrinsic impedance. Okay, so how to calculate the intrinsic impedance? We can use the formula J omega mu divide sigma plus J omega epsilon. Okay, so this formula you can find in your notes under the lossy mediums. Right, for J omega mu, okay, I already forget what is the parameter. Okay, is 4 and 1, and this is 10 negative 2. Okay, 4 and 1. So this is mu naught. Right. Alright, maybe I have to put the value 10 power 9 pi and mu naught. Okay, because the relative permeability is equal to 1. So this is 10 power negative 2 plus J 10 9 pi, and this is 4 and epsilon naught. Okay, so for this case you have to use the complex, okay, the complex mode in your calculator, and this is actually the option number 2 when you press the menu. So after you get this setting, you will see a symbol of this or I at the top of your calculator. So this, you are in a complex mode. So you can key in this and this, but don't key in the square root. Okay, so the complex mode cannot solve for the square root calculation. So for the square root, you need to do it manually. So I key in fractions. So I have I. Okay, so I key in the I. I put the I behind 10 power 9 pi multiply shift constants, okay, to get the mu. Right, and behind I put the I. Okay, then I have 10 power negative 2 at the bottom, okay, plus 10 power 9, okay, pi multiply 4 and epsilon. Okay, so remember to put the I. Okay, so I set my answer to be displayed in a polar mode. Okay, it means that I get my value equals to 35338.99. Okay, and my angle is radian 0.089. Okay, right. Okay, so this we have to do it manually. Okay, so meaning that I have to square root this manually, and for this one I will divide with 2. For the angle you will divide with 2. Okay, divide with 2, and for this you do the square root like usual. Okay, so I square root 35338.99. So I get 187.99. Okay, And for the angle, I divide with 2. So I get 0.045. I divide with 2 radians. Okay, so this is the intrinsic impedance. Okay, so I'm going to put it in this formula. So for the H is equals to 30, right? What is the amplitude of the electric field is 30, and the angle is 0 over 1 at 7.99, and the angle is 0.045. Okay, so value 30, I divide with 1 at 7.99. Okay, so you get 0.1595. Okay, 95. Okay, and for the angle, 0 minus this. Okay, so become 0.045. Okay, so this is the amplitude of your magnetic field. So we write down, okay, 0.1595, right, and exponents, negative 0.94 y. So I have cos, right, 10 power 9 pi t minus 21 point, all right, forget 21.02y, and plus pi over 4, and then you have to minus, okay, minus 0.045. Okay, and the direction of my H is x directions. Okay, I can combine this and this, right? So pi over 4 minus 0.045. So I have 0.74. So I'm going to combine them. Okay, 0.74 in the x directions. Okay, so now question asking, okay, what is the magnetic field when the y is 2 and the t is 2 nanosecond, right? Is it 2 nanosecond? Let me confirm back. Yeah, 2 nanosecond. So put in the value. Okay, so 0.1595 exponent, so multiply with y. Okay, so y equals to 2, right? So is minus 1.88, right? And then cos 10 power 9 pi t. Okay, so I'm going to do the calculation straight away. 9 pi multiply with 2 nano. Okay, is 2 pi. 2 pi, right? Minus, okay, 21.02 multiply with the y equals to 2. I get 42.04. Okay, and plus 0.74 x. Okay, so let me 2 pi. Okay, so this is my answer. Okay, so if I did the calculation wrong, let me know. Okay, so this is the magnetic field, okay, at the positions y equals to 2 and at 2 nanoseconds.